The Gippsland Basin is home to Australia's largest oil field ever discovered. From this basin, more than 4 billion barrels of oil have been produced, enough to fill over 630 billion litres, or the equivalent of millions of tanker trucks stretching across the country. At modern prices, that oil is worth well over 500 billion Australian dollars, and at the centre of it all sits one field that changed everything, the Kingfish Oil Field. Its story isn't just about oil, it's about a near-perfect geological alignment that turned a quiet stretch of ocean into the most productive petroleum system Australia has ever known. Out in the Bass Strait, the surface gives nothing away. Cold water, strong currents, and empty horizons. But beneath that water, buried thousands of metres below the seabed, sits a geological system that took tens of millions of years to assemble. Kingfish was not simply found. It was the end result of a chain of events that had to happen in exactly the right order, at exactly the right scale. The story begins with the formation of the Gippsland Basin itself. During the breakup of Gondwana and the opening of the Tasman Sea, the crust in southeastern Australia stretched and thinned. That stretching created space, deep depressions where sediments could accumulate. Over time, rivers, deltas, and shallow marine systems filled that space with enormous volumes of sand, mud, and organic material. This sediment pile became what geologists call the Latrobe Group, one of the most important petroleum-bearing sequences in Australia. Within this sequence, something critical happened. Organic-rich material, plant debris, algae, and other biological matter became buried deep enough to be subjected to heat and pressure. Over millions of years, this material transformed into hydrocarbons. This is the source of the oil. Without it, nothing else matters. You can have the perfect trap and the best reservoir in the world, but without a source, there is no oil. But generating oil is only the first step. It has to move. As hydrocarbons form, they migrate upward, driven by buoyancy. They move through porous rocks, along faults, and through any available pathway, searching for somewhere to accumulate. Most of the time, they don't stay put. They leak, disperse, or are lost entirely. For a giant field like Kingfish to form, that migration has to end in a trap. That trap, in the case of Kingfish, is a broad structural high formed on what's known as the Latrobe Unconformity. This surface represents a period of erosion followed by renewed deposition, and it created subtle topography beneath the basin. Oil migrating upward encountered this high point and began to accumulate. Over time, more and more hydrocarbons followed into the structure, building a massive column of oil. But even that isn't enough. You also need a seal. Above the Kingfish Reservoir sit fine-grained sediments from the Gurnard and Lakes Entrance formations. These rocks are impermeable. They act like a lid, preventing the oil from escaping. Without this seal, the oil would have continued migrating upward and been lost. Instead, it was locked in place, preserved for tens of millions of years. The reservoir itself is made up of lower Eocene sandstones deposited in deltaic and nearshore environments. These sands are porous and permeable, meaning they can both store oil and allow it to flow. But they are not uniform. They were laid down in shifting environments, channels, bars, and shallow marine systems, creating layers that vary in quality. Some zones are clean, well-sorted sands with excellent flow properties. Others are mixed with silt and clay, reducing their effectiveness as reservoirs. This variability is one of the defining features of Kingfish. It is not a simple homogeneous tank of oil. It is a complex geological system where some parts produce extremely well and others barely flow at all. Understanding that complexity has been key to managing the field. When the discovery well, Kingfish 1, was drilled in April 1967, it confirmed the presence of a massive oil accumulation. But even then, the full scale wasn't immediately clear. Seismic data over the field was distorted by overlying sediments, making it difficult to accurately map the structure. It took additional wells and improved interpretation to fully define the field. Once that happened, development moved rapidly. By 1971, oil was flowing. And not just flowing, surging. Production rates exceeded 180,000 barrels per day, an extraordinary figure for Australia at the time. Within a few years, tens of millions of barrels had already been extracted, and it was clear that Kingfish was something special. To support this level of production, a vast offshore infrastructure network was built. Platforms were installed above the field, each one supporting multiple wells drilled into the reservoir below. Subsea pipelines connected these platforms, transporting oil and gas to shore for processing. Over time, this network expanded across the Bass Strait, forming one of the most significant offshore energy systems in the country. At its peak, Kingfish and the surrounding Gippsland Basin fields supplied a major portion of Australia's domestic oil demands. For decades, the region was the backbone of the nation's energy security. It reduced reliance on imports and demonstrated that Australia could produce oil at scale. In total, the Kingfish field itself is estimated to have contained around 1.1 to 1.2 billion barrels of recoverable oil. At modern prices, that equates to roughly 140 to 160 billion Australian dollars worth of crude. But its true impact goes beyond that number. It enabled the development of the entire Bass Strait petroleum province, which has produced more than 4 billion barrels of oil in total. As production continued, the focus shifted from discovery to optimization. The easy oil, the oil that flows naturally under pressure, was extracted first. Over time, reservoir pressure declined, water began to encroach, and production became more challenging. This is the natural life cycle of an oil field. To manage this, operators turned to increasingly sophisticated techniques. Detailed 3D geological models were built, integrating seismic data, well logs, and core samples. These models allow geologists to map the internal structure of the reservoir in high resolution, identifying the best remaining zones and planning new wells accordingly. This is where Kingfish became as much a technological story as a geological one. The ability to continuously update the model, refine interpretations, and adapt development strategies allowed the field to remain productive far longer than it otherwise would have. Faults within the field also played a key role. The northwest-southeast trending normal faults not only influenced the original trapping of hydrocarbons, but also affected how the reservoir behaved during production. Some faults acted as barriers, compartmentalizing the reservoir and trapping oil in isolated pockets. Others acted as conduits, allowing fluids to move more freely. Understanding which faults did what became critical. Drill into the wrong compartment, and you might hit water instead of oil. Target the right zone, and you could unlock a previously untapped pocket of hydrocarbons. Today, Kingfish is a mature field. Production continues, but at reduced rates. The focus is now on maximizing recovery from the remaining oil while managing the challenges of an aging system. Water production is higher, pressures are lower, and the infrastructure itself is decades old. Offshore platforms still operate above the field, connected by pipelines and subsea systems. Wells continue to produce oil and gas, which are transported back to shore for processing. But alongside this ongoing production, a new phase has begun: decommissioning. As fields in Bass Strait reach the end of their economic life, infrastructure must be safely removed or repurposed. This involves plugging wells, dismantling platforms, and ensuring that the marine environment is protected. It is a complex and costly process, but it is an essential part of the life cycle of any offshore oil field. In many ways, this final phase is just as important as the discovery. It marks the transition from extraction to restoration, from production to closure. And yet, even as Kingfish declines, its legacy remains immense. It proved that Australia could host world-class oil fields. It drove the development of offshore exploration and production technologies. And it provided a template for understanding petroleum systems in similar basins around the world. What makes Kingfish truly remarkable is how perfectly its geological system came together. The source rocks generated hydrocarbons. The migration pathways delivered them to the trap. The structural high concentrated them. The seal preserved them, and the reservoir stored them. Each of these elements is essential. Remove any one of them and the system fails. But in Kingfish, they all aligned, at scale, and at the right time. That is why, decades after its discovery, it still stands as Australia's largest oil field ever discovered. Not just because of how much oil it produced, but because of how unlikely it was that it formed at all. I hope you found this as interesting as I did. And as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.